2022. It's so exciting. We've got a whole week of fun stuff ahead. For those of you who've just joined, my name is Kate Robson Brown. I'm director of the Jean Golding Institute, and it's one of the pleasures of the job that I get to introduce and host some of the great events we've got this week. So before we get started, just a few bits of housekeeping. This section is being recorded, and if you could make sure you've read through our JGI code of conduct, that would be great. It's going into the chat now. Please mute your microphone unless stated otherwise by the presenter or speaker or me. It'd be great if you could complete the registration form that's in the chat so we know a bit about you and where you've come from, and definitely the feedback form, as we're always on the lookout for a bit of a gap analysis. What have we missed? What would you like next year? What would you like to co-produce with us next year? So it'd be fantastic to have your suggestions. And please do introduce yourself in the chat box. It's hard to do networking with these online events, but let's give it a go. It'd be great to know where you're from, who you are, and what you're interested in. We're going to use Slido for questions for this session. So if you just go to slido.com and enter in that code 3088517, that will allow you to put some questions in, and then we'll have a question and answer session at the end. It might develop into a more free-form conversation, but let's start with Slido in the first instance. And many of you in the room will be friends of the JGI already, but for those of you for whom this is new, we're one of the University of Bristol's research institutes, one of 5, and we have 4 kind of key priority areas for our work, which you can see represented by the verticals on this infographic. And they are societal challenges, data realization, data visualization. Generally, it's a bit wider than it sounds there. Reproducibility and data governance, so that includes data ethics, data hazards, data governance, and fundamental or foundational research. And we deliver those ambitions through the series of cross-cutting mechanisms that you see in the pink arrows going along the screen there. So that's developing communities activities, so events just like this, training and professional development, which we do not only during Data Week, but throughout the year in collaboration with our partners. We are the portal for the Alan Turing Institute, the relationship between the Alan Turing Institute and the University of Bristol. Bristol is one of 13 Turing University partners, and I'm the Turing University lead on that. And within the Turing, I chair the Research and Innovation Advisory Committee. So we're quite involved in the management of Turing as well, which is great. And we also run an Ask JGI service. That's a kind of data science surgery, if you like. So you can contact us via the app JGI through the Slack or email with your data science query, and we will do our level best to triage that and give you a response. And sometimes those small requests turn into great collaborative projects. We've got several projects ongoing at the moment, which are externally funded, that involve data scientists in our team and arose through the Ask JGI service. So please don't be shy, come forward with your query and we'll see what we can do to help. This is day 1 of Data Science Week, as I said, and you've probably all seen this interactive because you're here, but I'm really proud of it. I think they did a great job with all the color coding. So you can see from this, we've got fantastic parallel sessions throughout the week, a mixture of talks and workshops like this one, networking opportunities, and lots of training events there. So do kind of find your pathway through the week and come to the things that you think are going to really help your career development. That's what we're all about. And a quick thank you to all our sponsors and partners that have made this week happen. Some really long-standing partners represented on this slide, like LV General Insurance, some new partners coming in that we just started working with, like Roche, fantastic. So we wouldn't be able to do this without you, and we're enormously grateful. Thank you so much. And now it gives me huge pleasure. I'll just unshare that for a moment so I can see people's faces. There we go, that's better. And now it gives me huge pleasure to introduce our speakers for today, who all come from the Office of National Statistics, and they're going to be talking about data science projects, training and case studies. And I think this session is going to be kind of 2 parts. We're going to have some talking at the beginning from Dr. Penny Holborn, who's head of faculty, Data Science Campus, and Jerome Mindlemon, who's a lecturer at the ONS FCDO hub at the Data Science Campus. So I think that's going to come first. And then second, we're going to have Andrew Banks, who's the lead data scientist, talking about some case studies. So I shall hand over to you. Thank you so much for joining us this morning.
Thanks very much, Kate. Very happy to be here. Thank you for having us. I think, Penny, I think maybe to start, it might be good to just do a quick introduction from yourself and myself, and then maybe Andy or Andrew can introduce his section when he joins, when he starts his part later on. Does that sound good?
Yeah, that's all great. Thank you. Would you like to go first?
Yeah, I can go first. So hi everyone, my name is Jerome Mindlemon. I'm a data science lecturer in the ONS FCDO Data Science Hub as part of the Office for National Statistics. So my role sits across the ONS, the Data Science Campus, and the Foreign and Commonwealth and Development Office, where basically a lot of my role is to do with developing training materials and working on data science capability building with our international partners. So through the FCDO and through our international team at the ONS as well. So a lot of the work focuses on initial introductory training in data science techniques. So that's R and Python, for example, building skills around automating existing statistical processes, and also building up towards machine learning and the sort of more technical aspects of data science. Penny?
Yeah, thank you for that. So I'm Penny Holborn and I'm the head of faculty within the capability team at the Data Science Campus. So our faculty team and the wider capability basically have the responsibility of developing and delivering the training programs that come out of the campus and wider. So one of the main elements there is, say, our Data Science Graduate program that runs across government organisations and public sector in sort of upskilling analysts and sort of bringing graduates to develop their data science skills, as well as a whole host of other sort of ad hoc training initiatives, research and projects that come out of the campus as well. So yeah, we've recently just finished supporting on the Data Science Festival with which one of these sessions that we delivered there as well. So yeah, great to be here today and thank you for inviting us. And yeah, I'll hand back over now for the session.
Thanks, Penny. I shall try and share my screen. I said earlier, this is a slightly unfamiliar computer for me, so I'm hoping there won't be any technical issues, but I'll do my best. So I shall share some slides here. Here we go. I hope everybody can see these okay at the moment. I'll have to try and
yeah, that looks good.
Buttons. Fantastic. Bear with me while I put that on slideshow. Here we go. All right, so for this first part of the session, basically what we were hoping to do is to talk a little bit about the sort of, I guess, initial phases of working on data science projects. So this is maybe as a sort of a little bit of context, a little bit background here. This is really talking about, I guess, what a lot of people would describe as the non-technical aspects of data science. So the kind of the aspects that perhaps when you would, as a new data scientist, start in the field, or when you, for example, come to work in the data science campus, perhaps wouldn't be the first thing that would spring to mind as doing data science, if you will, but it is, as I'll hope to convince you in the next sort of half an hour or so, a very, very important part of actually working as a data scientist and producing sort of successful data science projects. Just again, as a sort of slight housekeeping point, I said unfamiliar computer, but also I can't see anybody's chat functionality. So if anything comes up while I'm talking, or if there are any immediate questions, then please somebody somehow let me know. Or if there are any technical issues that I'm not aware of, give me a shout. So I think I'm right in saying that there'll be plenty of opportunity at the end of this first part to ask questions. But if there are questions that come up throughout that are just points that are unclear or things that are really unclear, just let me know and I'll try and address those while I'm talking as well. Right, so planning and scoping a data science project. So just as a quick outline, what I'm kind of hoping to do for these for this first session is initially maybe just give a bit of an illustration, a bit of background as to why planning and why scoping is so important for successful data science projects. I'll do that a little bit through giving three sort of brief examples of projects that we've worked in our small team in the data science campus at the FCPO Hub, to just illustrate kind of what these projects have in common. And perhaps some were more successful than others, and so they all have their individual sort of like quirks and challenges. But the key thing here is to sort of illustrate how the kind of scoping and what the kind of commonalities are across these projects as to how that fits together. Well, then sort of the main chunk of the talk will be to do with what I kind of set out as three sort of key phases of planning and scoping a project. So that's the initial scoping, impact and feasibility work that you might do. Then a very key part of where you're clearly setting aims and objectives. So you're really working through sort of setting up details for that. And a third part, talk a little bit about the practicalities that come into that. So again, just to highlight, this particular session really focuses on the planning and the scoping. So this is the kind of work that we're expecting to happen before kicking off a project, or at the very early phases, at the very least. So it's not so much about the delivery of the project. It's not so much about the actual doing of data science. And again, I'll come back to that a little bit later on as well. As I said, there'll be a questions and discussion session afterwards, and we can fill that in whatever shape or form is suitable for people at the time. Right, so we're all data scientists, or at least from the perspective of what we're talking about here, we're all interested in data science at the very least. That's kind of why we're all here. For that reason, I guess we're all interested in the techie bits. We're all interested in kind of fancy machine learning models, or using high performance computing to solve problems, satellite imagery, maybe using drones or particular software tools to help us solve problems. So we love those techie bits. We want to do all the techie bits. We're data scientists. That's what we'd like to do. We're even quite good at planning which of those tools to use, which of techniques to use, maybe what type of codes, or what type of coding language, or what type of coding we might want to do to approach a certain problem. But there's a much wider aspect around planning and scoping data science, particularly when it comes to project work, and particularly when it comes to project work that we need to deliver externally for external stakeholders, for example. So we want to think about who our stakeholders are. We need to know who we're actually doing the work for, why we're doing it, and kind of what desires and needs are for the work that we're trying to deliver. We need to plan to work together. We need to know kind of who our team is, what other team what we might want to work together with. External stakeholders, again, that we need to work closely, for example, to actually get the data or to set something up that is actually used in the long term. We might want to think, well, we need to think about the resources that we need to do project work, both financially and otherwise. And we need to, crucially, and I think this is something that I will keep coming back to, and it is something that's, I think, recognized widely, but perhaps not talked about very much, is we need to understand the wider context in which we're doing our work. So why, as I was saying, in terms of talking to stakeholders, why is it necessary, but also the sort of the broader point of kind of, is the work that I'm actually doing, how does that fit into other work that stakeholders might be doing, other work that other organizations might be doing within our organization. So that sort of context thinking is really important. And all of this stuff, I would argue, and again, I'll come back to this, even as a data scientist, a technical data scientist working on a particular problem, developing a machine learning model, I would argue for everybody in the team, it is important to understand all of these things and have a good sort of like grip of kind of those sort of higher level aspects of a project. So why is planning so important? What makes a successful data science project, I guess, is the sort of next question of that. So planning for success, I guess, what do we need to think about? So we need to sort of know that we have a team with the right skills. So we need to know who is in our team. We need to have particular skills. And this is something, again, we can come back to in the discussion that we spent in the data science campus, particularly in the capability sections and the faculty that both Penny and myself are part of. We spent a lot of time talking about the sort of the skill sets that we're looking for in, I guess, modern data science, particularly in government. We need to know that we can actually do the project materially, so that we need to think about projects that are feasible given the resources. So these are financial resources here, money. We also need to know that we have the time, the staff time available. Perhaps you need like what I would term physical resources, server capability or server capacity to actually do the data science you want to do. We need to know how to communicate both internally and externally, and we need to have systems and processes for that in place. We need to be able to deliver on time. So again, we need to communicate with our stakeholders internally or externally to have a clear idea of the sort of time frame over which we're delivering a project. Crucially, we need to understand how our work is going to fit within sort of organizational context and priorities. We work for the data science campus. There are certain themes that we're interested in. There are certain themes that organizationally on a higher level are set as priorities, things that are particularly interested. Your organizations might be different, they might have other priorities. So I can pitch any work I like, but it needs to ring with people who actually decide what those priorities are. You might want to make a business case, you might want to make a good proposal that says this is what I'm wanting to do as a data scientist. You might have that opportunity, but it needs to fit because otherwise it will be difficult to get work done. Crucially, we need to respond to stakeholder needs. And again, coming from the perspective of being part of the data science campus, being part of the wider Office for National Statistics, as a government organization, we work with a range of different partners and a range of different organizations. If I'm talking, for example, a lot of the work we're doing in our little team is to work with foreign national statistics officers. I need to understand what it is they need to do, what it is they can do, what it is they can't do, how we can support them. So talking to stakeholders is absolutely crucial, understanding what their needs are. And arguably, this is something you need to do really early on and develop a clear understanding of. We need to obviously know that our work is going to have some sort of impact, some sort of longer term impact. And again, engaging your stakeholders early on is really important for this. Communication is really important for this. Making sure that we actually deliver a product that's actually wanted is absolutely key. And obviously, we need to understand from our stakeholders' perspective, what are the outputs that we're actually aiming for? Do we want to deliver a dashboard? Do we just want to deliver a report? Do we just want to essentially have a pilot project, for example? All of that's fine, but an understanding of specifically what is expected and what is wanted is really quite key, because it will shape how you're going to approach from day one the work. So all of this might seem really obvious, and we all might do this naturally. But I would argue that a lot of data science training in particular is often not to do with these specific themes. It is often very focused on the technical aspect. It's very focused on coding, very focused on learning machine learning, and not so much about all of this other stuff that really has to be in place first to make a project successful. So this is just to highlight these different themes, these different aspects that make successful projects. So as I said, just as a kind of like an attempt to sort of illustrate kind of how projects might be structured and the different commonalities between different projects in data science. So I would argue that there's, in terms of a commonality, and you can split this up in many different ways, and this is just one way of doing it. This is just one approach that I took when we were creating these slides and we were thinking about this. One way of doing this is thinking of a project, a data science project in particular. This is probably broader than just data science, but think of data science here as the example. Splitting a project into an input phase, a construction phase, and an output phase. Now, the input phase would be doing the sort of stuff that I was just talking about, really thinking about the why of a project. What's the problem you're actually trying to solve? Who are your stakeholders? Why are you doing it this way and not another way? Is some other way better? All of those conversations. What's the organizational context you're working in? Does it fit within priorities? You might then move later on into a construction phase. So that's about the how. So what are you going to do? And how are you going to do it specifically? So what are the techniques and methods you're going to use? What coding languages maybe? What are the data architectures that you need to think about, the storage considerations? Are you going to use machine learning, maybe some natural language processing? Quite often, this is kind of seen as the core data science aspect. So this is quite often what you talk to people about. Planning. If I ask people what do you consider planning a data science project, quite often people would come back and saying, oh yeah, I'm going to use NLP to solve a particular problem, or I'm going to use drones to collect lots of data on land use, for example. So the third phase would be the output phase. So that's the kind of what, if you will. So what's the product you're going to define? So here, a project needs to have a defined outcome or output at the end. So a report or a dashboard, for example, as I mentioned. So this is where you need to understand the stakeholder needs, which is going to input how you're going to deliver the project, how you're going to maintain it, and also centers around questions of usability. What are you actually expecting to happen after this? Are you going to expect to influence policy, for example, and who by? So before I come back to this, I wanted to give three quick examples of projects that we've worked on in the FCDO hub within the data science campus. So one of the projects we've worked on is a project that we're referring to as REX, the Results and Evidence Exchange for the FCDO. So this is basically illustrating how you might break up these projects in these different categories. So the why here was we needed to provide our colleagues in the FCDO with a better system to track international development program results. So these are the way data are collected on these results. Data are collected varies massively between different projects. It can be quite messy. There are all different sort of ways of collecting data in spreadsheets. One project does it one way, one project does it another way, which makes it really difficult for the FCDO to track how they're doing in terms of investment, for example. So here, the stakeholder was very clearly defined as the FCDO and their partners in terms of the international development aspect. The what was developing a web application interface, and the how was basically through web development, lots of stakeholder liaison, really understanding what the different projects that we wanted to report on. So basically delivering a better common system for collecting results data within the FCDO. Second example, a project working on Uganda, on tree planting in Uganda. So this is essentially a project that was done through the Welsh government, or with the Welsh government as a key stakeholder, as well as local partners in Uganda. And this was all about tracking and reporting results of a tree planting program that the Welsh government was supporting, or is supporting there. And basically it involved a lot of satellite image processing, some machine learning in Python. But basically, again, this was about analyzing and reporting and presenting on what the actual outcome was of this tree planting program on a large scale using some clever machine learning techniques. The third project, what we refer to as VAWI. So this is basically a elections monitoring research project, where basically we were working with a stakeholder called Westminster Foundation for Democracy, who manually monitor a lot of discourse, online discourse around elections, particularly in Africa. And they want a better system to do this that does it more automatically, if you will, particularly focusing on toxic discourse as targeted at women and girls in particular around election times. So again, very much this was about developing a tool that could help people report, that could help the stakeholder report on how this discourse developed, and we proposed doing that through a dashboard to display these results. So the how here, instead of your satellite imagery, involved a lot of natural language processing, a lot of database management, a lot of setting up of the sort of data infrastructure behind it to collect this data from social media platforms. So what I wanted to sort of illustrate or highlight with these three examples here, if we go back to the sort of common sort of pillars of projects, so the input, construction, and output pillars, is that this construction phase, which is often seen as the kind of central core data science part, this is actually, interestingly, a highly variable aspect if you compare across projects. So we saw in the elections work, that's NLP. In the Uganda tree planting work, that's kind of a lot of satellite imagery processing. And in the REX work, it was really about understanding projects for the FCDO in particular, and lots of kind of web development, if you will. So a lot of the kind of techniques and methods used across these projects are actually quite variable. Majority, if not all, of data science training, I would argue personally, is pretty much focused on this part only, even though it's highly variable. These two, though, the input and the output phases, the why and the what, the kind of questions are, what's the actual problem you're trying to solve? Why are you trying to solve that problem? And the what, as in what's your actual project, all of those things are common to all data science projects. While the technical aspects vary quite widely, it's these two phases that are common, and we keep returning to the same questions. What's the actual problem? Who are you working with? Why are you doing it? What is it you're trying to establish? Is that going to solve a problem effectively? And it's these two phases really that are absolutely vital to have an effective data science project with impact, where you're actually going to make a difference. Right. So knowing that, I guess I hope I've kind of convinced you that those that logic sort of stands, that it's those two phases, and particularly that scoping phase that's so important in terms of thinking about up front. Basically, I'm going to come back to I guess the more structural suggestions as to how you might approach this as a data scientist. For example, this is very much coming from the perspective of working in the data science campus, but I would argue this process that I'm going to outline would apply everywhere. It would apply to pretty much basically based on research project development. So it hopefully will have lots of relevance for people here. Right, so 3 parts. First part, the scoping and impact and feasibility assessments. So the initial work, if you will. So the key questions here, and the key sort of thing that is absolutely vital to do first, is really understand what the ask is, and crucially, who is asking. So this is about your stakeholders. This is about the people that you're actually doing the work for. So this could be internal. It could be your internal team, your boss maybe, or your boss's boss. It could be the wider organization, but it could also be external. And quite often, in our case, in terms of working for the data science campus, it quite often are external stakeholders. So working with the UN, the World Bank, the Ghana Statistical Service, the wider Office for National Statistics as well. That maybe counts as more as an internal stakeholder, but all of these are stakeholders. And I should really sort of stress here that we mean stakeholders very broadly here. It's literally everybody who has a stake in this particular project, who has an interest in it. Then the next question, what problem will the work solve? What is it you're actually trying to address? What is the need? And this is really where talking to your stakeholders explicitly at length comes in. This comes from a perspective of working, for example, with the Ghana Statistical Service or the statistical organization in Rwanda, where we've really come to the conclusion that to work effectively with partners anywhere, you need to really understand what their actual ask is. So that sounds funny because you'd think they'll tell you, but quite often you would have to go back to people to kind of really understand, okay, you've said you want us to develop a dashboard, but would this not be a better solution? Or would X, Y, or Z not be better? To have that negotiation early on is absolutely crucial to avoid problems later down the line. If this is kind of specified up front, you will have a much sort of happier time of it later on. And one way of doing that, one way of really kind of trying to get at that, is to understand where it is you want to get to and communicate that back to your stakeholders. Say, okay, they've asked us for a dashboard. Let's analyze what they're actually trying to solve. What's the problem they actually have? Is a dashboard actually going to be the best thing for them? Define an outcome and then work backwards and say, okay, for us to get to that dashboard that's based on the machine learning model, we need X, Y, and Z. And by doing that, if you work backwards from the expected outcome, you'll be able to identify what tools or techniques would be most appropriate, what data you need, what access, who else you might need to talk to, etc., etc. So this particular sort of circumstance is absolutely crucial to ask questions and provide feedback. Basically say, come back to your stakeholder and say, is this what you're expecting us to do? Is this what you're expecting us to do? Can we do this better? Can you explain more about your particular problem? So understanding that fully, have that back and forth. The more you have of that, the better, in a way. So then as a sort of second phase of this scoping, impact and feasibility work would be centered around, I guess, what I would consider to be the more practical questions maybe. So the first one is, could you do it? So you've established that you want to do it somehow with your stakeholder, but could you actually do it? So have you got the resources? Have you got the people, the skills, the time, the data capacity, the modeling capacity to do it? Maybe you've then established that you could do it, but should you really do it? Come back to that point. Does it fit with what our team wants to do? Does it fit with what our organization does? Does it fit with our priorities? I work for, as I said, the ONS FCDO hub. So a lot of our work is focused on international work, particularly international work that is working with partners that are eligible for official development aid, which means that we as a team have to kind of prioritize a little bit in terms of whether we would do work with the National Institute for Statistics in Rwanda or the Vanuatu Statistical Office. Basically, there will be a trade-off in terms of the resources. We can't do everything. And assessing this fit upfront will inform how much you can go ahead. Crucial question also, why? So why would you take this particular bit of work on from a broader perspective? So for example, work in our case that might have lots of connections to the Sustainable Development Goals on Africa, for example, might be very high on our list. It might be very high on our list to support, for example, developing projects or work that is focused on gender equality and promoting gender equality globally, whereas work on just developing better processes for consumer prices index production might be lower down the list because it's got less, it's going to have less impact for us at that stage. And again, this does go back to the sort of like wider organizational plans that you're working in. The organizational plan for and the priorities for the ONS might be different to that for the Ghana Statistical Service, you found. So just to kind of briefly come back to the sort of, could you do it? The resources, the data, and this is kind of, I guess, specific to sort of data science projects in particular. Having access and knowing that you have access to the data that you're going to need for this project. Remember that I said the best way of doing this is working backwards, define where you want to go, work backwards, allow that process to let you inform what is the data we're going to need for this. Allow this process to allow you to go back to your stakeholder and saying, oh, you would like to use satellite imagery to quantify where fishermen are, for example, on a river. Can you actually do that with the data that is available? Even if you could, how much it is going to cost to get that data. So is the data suitable, and can you actually address the need? Can you get the data in the first place? Is it not going to be too costly? It allows you to go into sort of assessment of risks around availability as well. Data ethics is a big one. There's a lot of interest in web scraping, a lot of interest in using social media data to do all kinds of cool things, but there are obvious ethical considerations there that need to be considered upfront. The elections work that I mentioned earlier is a really good example. There were lots of issues around that we needed to work through, and indeed are still working through at the moment. Right, so the second part, and this is, I guess, something that's fairly close to my heart in terms of how I often see this developing with projects, broadly, research projects broadly. And that's kind of clearly defining and developing and taking time to develop a set of aims and objectives for a project. I'm not saying that this should be set in stone, I'll come back to that, but an ID, something that you've mentioned to somebody, chatted to over lunch, even wrote down in an email, is not a project. It's not an aim, it's not an objective. It might come close, but what is extremely important is to clearly phrase the aim of the work that you're going to do. So I'm saying take one or two, maybe three, maybe four sentences, a very short bit of text, write it down where you distill the expected outcome, the context, the stakeholders, the ask that you've had from your stakeholders, and all these other elements that we've already touched on, clearly written down in a very short bit of text. So, for example, this is an example I like to use because it's something we talked about with the guys at the Ghana Stat Service quite a lot. You could have something where somebody has said, we want to use satellite imagery to quantify land use in country or province X. Now, this is not well enough phrased. This is not a clear aim or objective. There's all kinds of issues that are missing here. So what you instead want to do is replace that text, satellite imagery to quantify land use in country province X. You might want to replace it with something like enable better decision-making in the Ministry of Agriculture by the use of satellite imagery to more accurately quantify land use and provide suitable tools for effective reporting on it. That's a mouthful. That's one thing. Also, when I was writing these slides, I remember a lot of feedback. This is version 3 or 4 of this particular sentence. I remember a lot of feedback saying, oh, that's not accurate enough, or oh, this needs to be different. So what you're trying to do here is not have the be all and end all, but what you're trying to do is have something that you can break down in these into these different elements. So this phrase, even though it's a mouthful, even though it's maybe not perfect, it includes a lot of the elements that I've highlighted here. So it includes what we're expecting the outcome to be, better decision making. It includes specifics of the stakeholder, the Ministry of Agriculture. It includes some comment on the sort of wider contexts, more accurately quantifying land use, implying that there already is a system to quantify land use, which we need to know about, etc. So building this out in this way is absolutely vital to have something that you can then refer back to at a later stage. Even if it's not perfect, even if you have to refer back to it to tweak it in some way or to have a discussion about it, it's really important to communicate the potential and the limitations of what we're trying to do. So we can use this. So we've had our discussion with the stakeholder. They want to do something about quantifying land use. We phrase this. We propose this back to our stakeholder and revisit the scoping. So we can refine it with our stakeholder during the scoping process, during this planning process. It may even, once you've actually started the project, it may even evolve. That is not a problem. So we're all about agile working. We're all about making sure that what we're doing is actually adaptable and can evolve in response to stakeholder needs. But upfront, I would argue it is really important to clarify these expectations and the limitations using this phrase. Or using this sort of clearly phrased set of aims and objectives. And as I said, I mean, you can have endless discussions about this. We did when we were writing these slides. You might want to replace the point about providing suitable tools for effective reporting. You might want to specify that into what we want to develop a reproducible analytical pipeline for reporting on this at regular intervals. Instead, you might want to change it with, we want to provide an interactive dashboard for the reporting. All of that's absolutely fine. And you will allow your stakeholder, you will have your negotiation with your stakeholders to really understand what it is they want. And by going through this process, which can be lengthy and sometimes tedious and sometimes challenging, by having this conversation early on, you allow your stakeholder to feedback. You might even allow your other team members, the data scientists, to actually feed into this process and saying, yeah, hang on, we're saying that we're going to do this, but this particular technique that we're developing isn't suitable to do this. So we might need to think about what it is we're promising. So having that sort of initial phase that provides everybody an opportunity to feedback on the plans and to kind of come up with something that's actually quite effective from day one. Once you've done that in terms of writing down your aim, you might want to start thinking about splitting your aim, enabling better decision making, etc., into sort of specific objectives that make a start at splitting the work into manageable chunks. So for this one, we might want to start with identifying and collating data, maybe satellite imagery, think about processing the imagery and generating summary statistics as a second phase, generating an interim report, and then building a tool for the output or the reporting at the end of this. Again, it's really important to stress, I'm not saying this should be like specified up front and you can't deviate from this path, not at all. What this process does help you to do is think about, okay, what are the skills that we will need? How much time we will need? Are there any other risks that are involved that we haven't previously considered? Does it meet the needs of the stakeholder? from our conversations with them, etc. So there's all kinds of, you can use this process to kind of work through all of these questions and hopefully address them as well. As a sort of final sort of part of this planning and scoping work, if you will, thinking about the practicality. So I would argue that the things that are on these last two slides here are really kind of the things that are probably almost universally the things that, if people are not talking about tools or techniques, are the things that people will always come back to if you talk about planning a data science project. So it's all planning all the practicalities like timelines and documentation and who's going to work on the project. But even going through these as sort of placeholders, as sort of indications of how you might go about doing this, I think is quite a useful thing to have as an explicitly stated list of things that you might want to think about. So documentation, and what I'm talking about here will be variable. It will be different between different projects, but early on, it is quite important to have some kind of research proposal, some sort of terms of reference or an outline agreement of what it is you're going to do. So this will include that set of aim, that aim and the set of objectives, etc., that I talked to before. It will state who the stakeholders are and what the resources are that you might need for it, etc., etc. Like I was saying, it will look different for everybody. The document that I've got an illustration of here on the right is the form that we use in the hub for mentorship agreements with different individuals and different organizations. And it does exactly that. It's essentially a mini project, if you will, where we are very clear about what we're expecting and who we're expecting that of. It also allows you to have bits in that on what ethics assessments you might need, what approvals you need to go through, what permissions you need to obtain to access data or to maybe even collect data if that's what you're doing. But all of these things there are placeholders for, or should be placeholders for, in this sort of documentation. The key thing is, and the thing that I want to stress, is to have something written down that you can refer back to. So again, if you have later sort of debates with your stakeholders or about the outcome of the project, you can refer back to what you said you were going to do. And there are numerous occasions already where I've had those conversations where it's useful to go back and say, actually, how had we phrased what we were going to do? Because maybe there's some misunderstanding that you need to clear up, for example. It also allows you to think about the sort of data architecture that you need. So the data sources that you're going to use, access that you might need, storage that you will need if you need, for example, large amounts of satellite imagery. Those are enormous files quite often that you quite often have to share between different machines. You need to have systems in place that can do that. If you're talking about, for example, developing web apps or web interfaces, so REX, for example, the results and evidence exchange tool that I mentioned earlier, it is very important to have an understanding upfront who is going to maintain that tool, where is it going to be housed, how does that work after the project's finished. So at some point you will have to have a handover to whoever is going to maintain it, and having an understanding of that before up front is really important. As an example, in my previous role at a university, we delivered several of these applications, and we never really got to a good situation where we had an application that we could maintain, because now that I've moved jobs, I don't want to be responsible for maintaining it. Am I expecting the team that is no longer funded to do that? Who is going to do it? So if we're expecting to have a long-term impact of our work, this is actually a really important point. And as we move towards more sort of interactive tools, web applications, dashboards, etc., to report on our research and our project work, this will become more important. Extra sort of a further aspect of sort of planning practicalities, planning timelines. Again, this might seem trivial and obvious, but planning when you're going to do what explicitly can actually be quite useful. Again, this doesn't have to be set into stone, but understanding whether or not you need to, like you're expected to produce interim reports, for example, is quite an important aspect, and it will affect how you're going to approach the rest of the project. Whether there are other project delivery deadlines, whether you have to have it done by a certain date, or whether there's a degree of flexibility with something, is all important in how you're going to approach it. Again, something that's, in my view, quite often glossed over and thought of as, oh, well, this is just something you do, obviously, planning your team. So a very silly question is, who is actually going to be in your team? Who do you consider to be your team? Quite often that is obvious because perhaps it's a very small team, but even in our small team, the hub within the data science campus of maybe about 10 people, it's not always obvious who is in the team. I've kind of gone in and out of different projects because there were different needs to respond to, and that's absolutely fine. But having a clear understanding by the people that you're expecting to be on the team is actually a useful thing to do. From a sort of planning perspective, thinking about skills distribution in your team is quite important up front. Say, if you need a web developer, for example, what happens if there's only one person who can do your web development in your team and that person leaves half the way through? I'm sure you can find someone else, but having others that can pick up quickly will sort of make things go a lot smoother there. So understanding how that skills distribution works is probably quite a useful thing to think about up front if you can. And yet again, at this point, you might want to sort of revisit the scoping and the objectives and kind of reconsider, actually, can we actually do everything we want to do without an undue amount of risk? Agree your modes of communication. Again, there's all kinds of things that come into this. Not everybody will be able to use Teams. I said I'm on an unfamiliar computer at the moment. I'm mainly on this unfamiliar computer because we can't use Zoom on our ONS machines, which means I have to use a different computer. Things like that, the communication aspect, not everybody can use GitHub or knows how to use GitHub. The Data Science Campus is pretty much, that's what our work is. So it's kind of understanding how this will work together, particularly with external stakeholders, is really quite important, and coming to an agreement on that to avoid problems further down the line. Timing, communication, what are you going to do and when? What meetings are you going to have when? Setting up a calendar up front, I would say, is a useful thing to do, even if there are just placeholders. And again, we want to make sure that we work in a slightly agile fashion, but even in an agile project management approach, there will be regular stand-ups, for example. There will be regular update meetings that will take place. So planning these up front, making sure you know who is going to be included, that the communication means work for everybody on the team, etc. Right, so that kind of brings me to the end of this sort of initial sort of part of the session. So just to summarize, I hope that I've given you or I've convinced you that this sort of planning and scoping aspect is, I guess, both fundamental to data science projects, but also something that perhaps isn't really necessarily thought of that much, particularly by data scientists who like to do the data science. The technical aspects quite often overshadow the sort of stakeholder engagement. So it's really important to sort of ensure that clarity on why you're doing work, what are you doing it for, and that will allow you to have the impact that you're seeking in the end. Yes, I would argue that particularly when you talk about this back and forth between phrasing aims and objectives and coming to an agreement on that, it is time consuming, but it is very much worth it for all those reasons that I mentioned, in terms of maximizing your impact, in terms of having a smooth progress through your project. And consider these details up front. Write things down. Absolutely. Don't just rely on things that you might write in an email, but have some sort of format, some sort of formal document you can refer back to in terms of reference, a project specification, project proposal, whatever you'd like to call it, whatever it looks like. Have something formal that you can write down saying this is what this project is going to be. And as a final point, I would sort of again stress that all of this process is iterative. I'm not talking about a linear process where you have to go from scoping to aims and objectives to practicalities, etc. That's not what I'm saying at all. We're moving back and forth between these phases. As we've seen, we might want to rescope things once we've talked through aims and objectives, or even when you come to planning practicalities, your team, you might want to go back to rethinking things. But communicating things with stakeholders, asking questions of them, being open about what is and isn't possible, we're the data scientists, you're the data scientists, we are the technical experts in these approaches quite often. So we can say, actually, what you're asking us is probably infeasible. And sometimes there might be a tendency to sort of try and just give people what they want, because people think that that's the way to sort of like get the project on the go and making sure we can make progress. But I would argue that it's always better to be honest up front, to say, actually, these are the technical issues, not be negative about it, but say, actually, this is something we can do, and actually we think that this really will help you solve your problem or address your particular need. So have that back and forth, and have that sort of as an interactive process. I think that is me. I have unfortunately absolutely no idea how long that took me. So forgive me if I talk very quickly or if I talk too slowly. But thank you very much for listening for this first part. And I think we'll probably just take some questions at this stage. Thank you.
Excellent. Thank you so much, Owen. That's great. We're on 10 to 1, just to let Penny and Andrew know. So maybe we'll just take a few quick questions. I'll have a look in the, there's a question has popped up on Slido. Okay. So if you want to look in the chat, you're in as well?
Yeah.
Do stakeholders often have clear ideas of end users and downstream impacts, or do you feed into this part too?
I would argue that we would certainly always feed into this part too. And I think maybe a distinction I wasn't making so much, I guess this is one of these things where you can talk about this at length, because one thing maybe I wasn't talking about so much explicitly is where you're working through a stakeholder that would provide that product to others again. So there's almost like a next level. And I think I would probably say that all of that, to my mind, comes under understanding stakeholder needs. I think if I would get wind of the main stakeholder wanting, for example, a dashboard, and that would be used for end users, maybe reporting on the census, for example. That's something that we've talked about with the African stakeholders quite a lot. I would argue that that's great, but we need to then understand that they really know what it is people to want, how they want people to use it. And in a way, that allows us to have a further conversation to say, actually, maybe it's not clear enough. And then we can go back to say, can essentially say exactly that. Say, actually, can we clarify what it is you're trying to achieve? Because maybe a dashboard isn't at all what you need. So we like making dashboards. I like making dashboards. Dashboards are great, but they only go so far, right? And we kind of, do we really need a dashboard for the wider public to get the information that you're producing? Or can you do the same with a good looking website that has all the essential information on it in the right way? So I think that's part of the task, frankly. Absolutely.
Okay, great question, thank you. And James has combined a few questions into one question for us, which is great. On the technical side of things, what range of programming languages and tools are commonly used at ONS? So
a whole range is probably fair. So I think at ONS, Python and R are big. PySpark for larger data sets and more substantial work are the kind of the main sort of tools that are being pushed at the moment, certainly. There are a range of other sort of specific applications that are used for census work, for example, as well. Admittedly, I don't know very much about those because the data science campus is a sort of a separate team within the ONS. Penny might have specific comments on that from our FCDO hub perspective. We are very much all about pushing open source tools in particular. So we're very keen on basically suggesting people to use Python and R in particular, and moving away from proprietary software just because that will allow access to a wider group of people. I was about to say reasons there, but that's probably not the applicable thing to say. Penny, did you have anything to add?
Yes, sorry. No, I think yeah, what you said there is correct. And for context, when, say, for instance, we run our data science graduate program, which is across government and public sector, we have recently done a big skills analysis, or needs analysis, probably is a better word, in terms of those stakeholders. What are they using? What's fit for purpose? What should we be teaching? And again, we have split between sort of Python and R across those users as the main sort of programming language, and that is basically then we deliver the program across both of those platforms. It's a bit of a weird one. The grads themselves have a preference of Python, but actually across our organisations we still see, especially more across the public sector organisations, a preference for R from the stakeholders themselves. So we do have a balance there, and again we look to push for everything sort of open source. We are seeing more and more requests for things like Power BI and sort of Shiny in terms of the visualization and the dashboard inside of things of what we do. And again, we've heard a little bit there around sort of packaging things up and pipelines and things being a big ask across government in terms of what we do. So, and again, geospatial, we've just finished a module which has some of its own requirements then around using sort of geospatial sort of packages and large data. But yeah, hopefully that answers your question.
That's great, and then that's obviously got some people thinking, because there's another question popped in. Are there any open or example documents that document your planning and processes?
Oh, that's a very good question. Penny, help. I can't point to anything specific, but I think the planning aspect is maybe tricky.
I'm sure there might be a couple, but I don't know specifically what they were looking for. For instance, there was a skills audit performed a few years ago that they did a very nice document in terms of mapping out how do you understand sort of like the current structure and the needs, or sort of how to plan a project. So there might be a couple of resources that we might be able to share that then there might be useful, Kate, or just check where they are and where they're sort of available at the moment. I think probably might be the best answer for that, to possibly follow up.
Fantastic. I think we'll have to leave questions there for the moment in the interest of time, and move on to your next section.
Fab. So I think I saw Andy just flash up now in the background. So I think, Andy, you're there. If you would like to get yourself ready and set up.
Great. I'll do.
Hi.
There we go. Can people still hear me?
Yeah, it's all good. Brilliant.
Jerome, I've just sent a presentation to you. I'm going to try and share my slides. If I can't, I wonder if you were able to share them and I could knock on the slides.
We can make you a
if that's okay.
We should be able to make you a co-host. James is probably on it in the background. Is that okay, James? Yeah, he said he's done it, so you should be able to share, Andy.
Can people still hear me?
Yep.
Fantastic. Okay. Jerome, I don't know if you are able to share the slides that I've just sent over to you. Is that possible?
I'll have a look for them, Andy. Give me 1 second. I'll have to actually move them across to the other computers, so it might be 1 second, but bear with me 1 moment and I'll try and sort that.
I wondered whether, Andy, we did some introductions just before we started, but whether while we get those set up, you wanted to sort of introduce yourself, because we've done our bits.
Brilliant. Okay, so really pleased to be talking today. So my name's Andy Banks, and I'm a lead data scientist at the Data Science Campus. So the kind of aim would be to sort of take you through a bit of the high-level mission of the campus, a bit of the work that we've done recently, and then I'll try and end. I'll do a deep dive into one specific case study of a piece of work which we've done fairly recently, and I'm happy to take questions about that one. And then maybe I'll just end with a few reflections on how the on factors that are kind of important for a kind of data science project when thinking about a data science project, and I'll try and link those things back to the case studies where possible, and then happy to take questions if that's okay. Brilliant. So really sorry, I've been having trouble sharing the slides. So yeah, so that's a bit of an overview. If I just go on to the next slide. So just talking a little bit about the campus in general. So really the aim of the campus is to be a leading light for data science in the UK public sector, and to do that we want to build software and tools for the public good, work on collaborative data science projects that inform policy and engage the public. We want to increase data science capability across the UK. And we also want to drive best practice and innovation in the field of data science. And we've just recently celebrated our 5-year anniversary. And over that time, we've seen a really rapidly changing data science landscape. One of the biggest changes we've seen is the emergence of a large number of data science teams across a range of organizations, not just in the public sector, but in think tanks, charities, and the private sector as well. And we're seeing groups of data scientists now conducting a lot of really interesting research and applying that to impact the UK, their organisations. And not that these teams are not just sort of being established across all these organisations. They're also growing in size, and I think that means that our responsibilities are changing as an organisation, and it means that we will increasingly need to deliver work with or for other organisations. So happy to talk about that at the end if people wanted to talk about that a bit further. Can we just go on to the next slide? So our mission for data science, our headline mission is data science for the public good. And that has been unchanged for a couple of years. And within that, we can separate out these our work into kind of 3 core missions or areas of work. One of them is explore, consisting of research and innovation to really ensure that ONS is on the is at the leading edge of what's possible with data science. The second is enable, which is all about improving data science capability across not just the Office for National Statistics, but the public sector more widely. And as I mentioned, that's increasingly important because you have all of these organisations now that do have data science teams. And so part of our role is in helping to improve skills and through training in those organisations. And then also embed, and this is increasingly something that we're looking to focus more on, which is around embedding data science into production. What does that mean? That means not just exploring what's feasible with data, but helping people to produce either regular statistics or forming policy through improved statistics, potentially those that which are available on a repeatable basis. And all three of these can obviously require different skills. But the explore side is still incredibly important because, as you'll see from some of the case studies, some of the projects that we've been working on have only been possible because we have done a bit of investigation and exploratory research into things. So if we go to the next slide. So if we first start with explore, and as I mentioned, this was really about trying new tools, innovative techniques and methods because we have a sense that these will be valuable, but are potentially a bit more risky activities, and we think that they may fail, and we need to have that risk appetite to sort of accommodate that. And if we go to the first example, one which is becoming increasingly important in all organisations really, but especially in ONS and the civil service, is this idea of synthetic data. And of course, organisations are increasingly asking us, are increasingly being asked to release more data, both to other organisations but also to the public on a whole range of things. And the ONS and the Data Science Campus and the Civil Service is no different. We want to better measure social and economic factors for different for people, but to do that with increasing levels of granularity and timeliness, what we really need to do is have a real focus on making sure that we are doing so ethically, and as part of that is not to release personal or sensitive information about individuals or individual organisations, and so synthetic data or sort of data synthesis, the use of algorithms to produce anonymous or versions of data which are anonymized is becoming incredibly important. And the process of replacing a data set with one that can be used, a disclosive data set with one that can be used for research, but and behaves in a similar way to the underlying data, but divulges no sensitive information. So we've done a range of exploratory work in this field. We've created models to generate synthetic data that are particularly useful when the real data are sensitive, and we've produced a literature review and comparative assessment of these models, which was featured in the Significance publication, which is on the right-hand side. And we've also built an open source tool, a Python library called SynthGauge, that provides a framework for evaluating synthetic data using a range of metrics and visualizations. And yeah, making code reproducible and open source is something that we really want to, both in the ONS and the Data Science Campus, improve on. There's increasingly guidance across government now to be open source by default. And that means not just using open source tools wherever possible, but also releasing the code that is being used to produce statistics and the data as well. So that's something that we've been doing recently. If you go to the next slide. Another recent project relates to the challenge of anticipating supply chain issues in the economy. And this is something which is particularly important at this moment in time, with events globally leading to shortages of certain key products, and that then providing potentially input cost pressure or product availability problems into the economy. So in order to try and understand this a little bit better, potential UK's resilience to supply chains, we've been trying to explore unstructured text data from a variety of sources, including government departments, market intelligence documents, to understand buyer-supplier relations in the economy. So I've given an example down at the bottom there, where we have used natural language processing, so named entity recognition and network analysis, to basically identify where a firm supplies another firm. And the idea of this is to build a large sort of database or network information, which will allow departments to better understand the interdependencies between firms and therefore the resilience, nature of resilience. So that's something else that's been explored. If we could go to the next slide. So obviously, just coming to embed, we, as I mentioned before, are aiming to build embedded solutions so that we can hand over tools, sets of statistics or pipelines to teams in government, including the ONS, so that the statistics that we produce or the data sets we produce can be repeated. So we're looking to produce new data sets, more granular data sets, more timely, insightful statistics, improved versions of existing data sets, and those pipelines as well. Ideally, open source wherever we can. Open source those pipelines wherever we can. So some examples of where we have already deployed data science and met some of this embed mission is through the use of shipping data. So if we just go to the next slide. So this is a project which started out as an explore project, but over time has found increasing amounts of application for us for a range of other statistics. So if I take us back to 2016, where the kind of the idea of the data science campus was first being formed, and in that initial inception of the organisation, there was an independent review of UK economic statistics by Sir Charles Bean, who was an ex-member of the MPC, the Monetary Policy Committee at the Bank of England. And what he said was that the longer a decision maker has to wait for statistics, the less useful they are likely to be. And that reflected at the time that measures of official statistics had a degree of lag to them when looking at the economy, and that was potentially around 2 or 3 months. And the argument that was being made was that wasn't fast enough for policymakers like the Treasury or the Bank of England to set policy in order to respond to changes in the economy. And so what we did was look to explore a range of different indicators that could be used to produce more timely or frequent indicators of economic activity. And one example started out as just a general exploration, which was AIS, real-time shipping data. So the idea that container ships that are holding goods and are going from different countries through port routes have a automatic identification system which gives their location and also a little bit of information about the ship in general. So what we did was we used that to produce an indicator of the number of ship visits to UK ports. So looking at every UK port, the number of ships that entered a port. But to do that, we needed to do a lot of research over a number of years to be able to understand the nature of the data, the quality of the data, how to store and process the data, and the use of algorithms to classify whether a ship was indeed entering and leaving a specific port. And there are different algorithms that you can use to do that, and they all have their strengths and limitations. So there was a lot of work done to refine those and understand the complexity and the ability to scale for such a large data set. So that was started out as an explore. What was produced from that was a weekly time series of ship visits to the UK. And that is now being used and published on the ONS website on a weekly basis in our publication, which is called Faster Indicators of UK Economic Activity, under the shipping section. So you should be able to go and see that time series and see how that changed during the pandemic. So that is an example of where we've embedded research, and to do that we had to be very considerate of how we built the pipeline to produce that weekly time series and provide that to the team in the ONS who would be able to run it and on a weekly basis. So really key is how you build and design code and pipelines so that the research and the indicators are repeatable. That's one example. If we come to the next example, so the next example is tracking the price of the lowest cost groceries. And this is a publication which was, or a set of statistics which were released about a week ago. And the background to why this project came about is obviously the real attention at the moment on the cost of living. So at ONS we produce a vast range of inflation measures, and our headline measure of inflation is the Consumer Prices Index. And I'm sure many of you will know about that. That's produced on a monthly basis and is a measure of how the average prices of items are changing. So both a mix of the cheapest and most expensive products. And that on that measure, price inflation rose very strongly from the second half of of last year, and food and drink inflation within that in the latest month, April 2022, has rose at the fastest rate since June 2011. So the context is the average prices are rising at an increasing rate. But we know that not everyone's, these are average prices. And we know that everyone's inflation rate will be different. And to reflect that, ONS did produce a personal inflation calculator, which allows you to put in different values for the amount that you spend on different goods and services. But again, those are based on average prices, so the mix of expensive and cheap products. And what we wanted to see was whether we could choose to look at how the very cheapest items were changing. And we know that people will may choose or have to choose the cheapest value range products to cut back on spending as much as possible. So we wanted to gain that insight, so how the cheapest prices were changing, but we also wanted to understand how much extra someone would have to pay for the next cheapest item if the cheapest wasn't available. And the reason for that was that, again, towards the end of 2021, there was evidence of increasing reduced levels of stock availability on the shelves. So if the very cheapest product didn't happen to be available, the difference between the cheapest and the next cheapest is important from a budget perspective. So to do that, could we just go on to the next slide? To do that, we collected data by scraping 7 grocery retailer websites on a daily basis, which amounted to many millions of price quotes and accompanying product information over the year. And we focused on 30 commonly bought food and drink items, which were items that survey data showed were more likely to be bought by those on low incomes. But it's worth saying that there was a whole host of other criteria that we used to choose that. And so it was not just based on that, it was also based on other factors. So for each of those 7 retailers and 30 items, we searched for the cheapest possible products that a consumer can choose from, and selected the cheapest price after adjusting for the size of the products. And we then constructed the average cheapest price for each of the 30 items and tracked that over the year to see how it changed. We weighted retailers based on their market share and the number of stores in areas where household income was very low. So just going on to the next slide. I think in doing data science, in conducting data science projects that are producing statistics or data, it's incredibly important to be clear and upfront about the strengths and limitations of the work that you've done. And so here I'll be clear on the limitations. Prices were based on what was being made available online. And it's worth saying that supermarkets may have different product ranges and prices to compared to the on-store online versions of the websites. So remember, this was just based on web scrape data. So that's one limitation. The second limitation was that in running web scrapers daily, for 7 different retailers, we did find challenges on the data collection side when product ranges were added or removed, or the composition of and design of the website changed. So all of those potentially added volatility to our results. The nature of the question meant that we could only look at the cheapest prices of goods, and so that meant that we had for every month, for every retailer and every item, we only had 1 price quote to draw our comparison on. And so the results were based on a very small number of price quotes compared to our official measures of inflation, which are in how they're constructed, much more robust. And where products were unavailable during the year, we replaced those items with the next available item. And there are a number of different ways you can do that through both complex and straightforward methods, and they all have a large effect on the results. So if we could go to the next slide. So to the results, there were a large range of price movements for the lowest prices, and there were a huge range. For 10 of the items, the lowest cost price increased by more than 10%. And for 5 of those, the price increased by more than 15%. But there were some items that fell in price, and there were some items that that rose in price, but at a lower rate than the official measure of food and drink inflation, which was 6.7% on the same basis. If we could go to the next slide. We could also see how products changed in cash terms. So, for example, the biggest rises in pence terms were for beef mince and chicken breast. So beef up 32 pence for 500 grams, and chicken breast up 28 pence for 600 grams. In relative terms, the biggest price increase was for pasta, which was 50%, around 50%. And we also constructed from the individual products an overall price index taking together all of the 30 items. And when we did that, that rose at around the same rate as the official measure for food and drink inflation. Could we go to the next slide? But in doing the work, we found that this is kind of potentially where evidence of embed projects then lead to further ideas for explore projects. Because when we did the work, we quickly found there were lots of other interesting questions that could be answered from looking at individual price quote data. And we calculated the difference between the cheapest and the next cheap. So one thing that we did was look at the difference between the cheapest and the next cheapest price for the 30 products. For over 2/3 of those products, the difference in price was at least 20%. And for 4 items, the difference in price was more than 50%. It was interesting that in kind of doing the work to look at the cheapest price, we then were able to see that we could then explore a bit more and do that work. We also identified by looking at the product information and the weights some evidence of shrinkflation, where pack sizes reduced but prices stayed the same. So again, understanding new kind of topics from data, just from a bit more of exploration of the data. And there are lots of other potential benefits of using the detailed product information. For example, looking at nutrition information to see if the composition of products have changed and how quality, quantity and price interrelate. So key takeaway is the huge amounts of interesting work that could still be done with that data. Could we go to the next slide? Yeah, so it's also worth saying here that there are other further data sets that could be used to make better that could yield improved quality and accuracy of these results. So one area that ONS are a really exciting area that ONS are looking to look at more into is electronic point of sale data for price statistics. And this is when someone goes to the supermarket and purchases products, that data is collected by supermarkets and essentially provides a census of price quotes, but also the quantities bought for those products. And that's an incredibly exciting and interesting data source because it's essentially a census, and from that, the price statistics more generally, including the consumer price inflation statistics, can be improved upon, both in terms of their granularity, the items that are being looked at, or the regions that are being looked at, but also the other factors as well. By nature, if you're constructing data from a greater number of samples, then in many cases the accuracy of those statistics are going to improve, and the quality of those statistics are going to improve. Can we go to the next slide? But it's worth saying that the aim for ONS is to make better use of electronic point of sale data like this, but local collection and web scrape data will also always be very important data sources for the production of price statistics. For example, for web scrape data, looking at how the quality of products changes for something like tech goods, like laptops and mobile phones, is potentially really interesting use case. Can we go to the next slide? Yeah, just very briefly touching on some of the enable projects that we do. So this is where we are looking at improving data science maturity of public organizations through advice, guidance, improving infrastructure around data science. For example, on the kind of competency framework, which advises on how data scientists can be recruited into the public sector, through training courses and programs that develop data science talent. So if we go to the next slide, I can give some examples of work that we've done in this space. 5 years ago, we launched a data analytics for government master's course, which was a joint initiative between ONS and universities across the UK. And that obviously supports it was a postgraduate course, so supporting students wanting to gain an understanding of how data analytics can be used in government. We've launched our data science graduate program, offering 50 places in 10 public sector organisations. This year, the demand for that has grown, and we're now offering places to 17 public sector organisations. We've run a data science apprenticeship where people from a range of career backgrounds and educational backgrounds can work with in government offices while studying for a degree, and a whole range of other initiatives. If we go to the next slide. Yeah, I think also worth saying that the data science community is incredibly important. As I mentioned, there are a number of other data science teams that are increasingly being started up in organisations, and those teams are growing in size. So it's important that the community continues to grow and flourish. We've done an awful lot in this space, including the Data Science Festival, which we run and organise, where the topic this year was to explore the core themes of Foundation for the Future, Future Impact, and Your Future. So looking at how we run data science projects, kind of endemic issues, challenges for the community, and including kind of discussions around ethical considerations, but also looking at skills and capability as well. So just so go on to the next slide. Yeah, just a couple of thoughts, I think, just reflecting on those kind of case studies on what some key factors for success are and have been. So if we could go to the next slide. Yeah, the first one that I would put really as a general point for kind of making sure that these case studies, these projects are successful, is to think about a theory of change. And I don't know the extent to which people here will have come across this, but it's increasingly being used in government to think about appraisal and evaluation of projects more generally. And I've very crudely summarized here, but kind of 4 key things to think about. And I often think that starting in the order that I've put here is important. But starting with impact, really thinking about what the impact of the work is likely to be, the aims, objectives, and success factors, and having that really clear in minds before going and starting a piece of work. I mean, I suppose this is not unique to data science. It could be also applied through a whole range of measures, but especially important for data science when perhaps the tools, techniques, and data are a little less certain. And so I think it's always really important to come back to the impact. Is the work that we're doing making an impact, and how can we make an impact? Then thinking about the outputs. So what will you actually want to produce in order to make an impact, and try and understand the link between your output and the impact, potentially through and potentially evaluating that. So are there metrics or data that can show how the outputs that we've produced have led to an impact, or continue to make an impact, especially through say retrospective evaluation. Activities then are important. So once you've got an idea of the impact you want to make and the outputs that you need to produce to make that impact, then thinking about the activities. So this is then more about general project planning and things like that. And then of course your inputs. So thinking about the time, space, and resources, technology, data that you need to have in place to kind of make all of that a success. And I think I've got two or three final slides just to sort of go into a little bit more detail on some of these. So next slide, please. Yeah, so through how can we best establish impact of our work? Well, of course, I think stakeholder and customer research is the most important thing. Or user research. So whether it's direct interviews or literature reviews or kind of or just general planning, understanding what impact the project should have and how we define that. And as I mentioned before, any KPIs that can be produced that to lead to the measure of impact, even if it's indirect, can help and you to evaluate the project to ensure that it's being successful. Next one. Yeah, I think outputs. Thinking about outputs is an incredibly important stage, because this is the key thing. I think is how do you want your how do you want people to use your product? How do you want people to make use of your product so that it can be impactful? So if it's a tool, thinking about the person that would use the tool, how could it be made as accessible as possible? Who is the customer that's going to be using it, and how are they going to be using it? So is it through a web application? Is it through an app? Is it through a set of visualizations? Is it just through a set of data tables? If it's through a set of data tables or through a set of statistics, how do you want people to be able to access those statistics? So if it's a set of public statistics, say, how would you know that people know where it is and can access it? Government would encourage you, if you're building a web app or an app that is to be used by customers, would really encourage you to look at government accessibility standards. So this is where guidance for those with disabilities, or for other general accessibility standards and criteria are kind of set. The framework and the set of criteria there are all all free and accessible for people to look at. So I would really encourage you to look at different sources like that to try and make your outputs as accessible as possible. I think then also in thinking about outputs, you also want to think about whether you're going to repeat the work or whether people are going to be wanting the service or the set of outputs on a repeated basis. And incredibly important then, if the answer is yes, to think about how the work can be repeated by you and others. So this is where packaging and test-driven development and thinking about your code base and the style of code, thinking about peer review, is the work going to get peer reviewed, or is the code going to get peer reviewed? Have you thought about user testing? So have you actually thought about getting your customer or stakeholder to kind of use the product that you're going to produce and do a bit of iterative testing with them and getting their iterative feedback? And so that's another factor. And if you're also going to be producing a tool or a product or a set of statistics that need to be repeated, it's also worth thinking about ongoing maintenance. So of course, all of I'm sure all of your products are going to be highly successful, and so they're going to be demanded by everyone, but you might not want to make feature improvements or enhancements, or you might want to resolve bugs. So I think it's thinking about setting out your time and space to be able to deal with that. Can you put something in place so that those things can be resolved? And a great example, one of the best examples for that, is the coronavirus data dashboard. You know, if you think about that web dashboard that everyone or at least every analyst in the country was looking at on a daily basis, their ability to make changes and feature enhancements and resolve bugs was incredibly impressive. And there are kind of these metrics for minimizing the amount of downtime that the service has if you are providing a kind of web app or a service, minimizing the amount of downtime you have, and then certain metrics for the time for feature improvements. So the time from committing a line of code to that being able to kind of be deployed on to the customer successfully is another thing that's incredibly important to think about. And next, final slide, I think. Next slide. Yeah, activities. I wouldn't go too much into the resources because that's I'm sure you think that they're self-evident, but yeah, certain activities. So thinking about how you package your code, test-driven development, thinking about if you're writing code, can you conduct automated testing, automated testing of your code, so that that you kind of minimize that time from commit to deployment, and you minimize the risk of introducing error into your service. And then also kind of other things like process maps, handover maps, thinking about who, if someone else is going to end up running your running your tool or running your service, or your sets of statistics or your pipelines, thinking about that as well. So that's all I had to say. I hope that was helpful. More than happy to take any questions on any of those kind of three areas, reflections, a bit more general information about the campus, or some of the specific case studies that I went into.
Andy, thank you so much. That was an amazing overview. So one of the problems with doing online events is that nobody gets a round of applause. But I wonder if we could just flick our videos on for a moment, or use the emotion to give you a quick round of applause. Everybody, thank you so much, Penny and Andy and Jeroen as well, for those fantastic presentations, really great. And now, got a bit of time for question and answer, and I'm pretty sure we've got some popping up in Slido. Let me just have a look. Okay, question number 1, which Elaine is putting in the chat for us. At a trusted institution like ONS, how do you balance releasing projects and data early in their development with waiting until they are fully tried and tested? That could go to anyone. Who wants to take that?
Yeah, it's a really good question. So, yeah, of course, there is a balance to be made, because on the one, it's worth saying that one dimension of quality in statistics is relevance. So you know, so you need to think about timeliness, you need to think about accuracy, you need to think about reliability, but relevance is incredibly important. So if we were to wait until statistics were gold plated before trying to answer questions that the public are kind of demanding, then we can miss the opportunity to inform the debate or the public on issues that matter. So a good example of that is on say the cost of living. You know, obviously really important questions that are being asked, and so then there was a real need for this work on the cheapest items. Now we would have had to have waited quite a long time for the census of records to be available, and for us to have the kind of the data in just the right format. But the data that the data we had could produce statistics that would inform the debate. And so I think the key thing to think about is really being clear on your strengths and limitations. So where is this data best used? Where is the data? What should people think about when looking at the statistics? Making that as clear as possible, and then also the communication of those statistics is incredibly important. So when we were putting together media notes for briefing and things like that, we were very clear to say that these are highly experimental statistics, and the ONS has a kind of a kite mark for national statistics, which are have been produced under the most robust methods and data, and so it's communicating that the statistics we release that are more timely you know, don't have that kite mark and are experimental, so that people can judge the difference between the different types of statistics.
That's great, thank you. And we've probably got time for one more. So there's quite a fun one that's come in. Could the cheap food tracker be used to identify where to get the cheapest item?
Well, this is probably another element where we need to be clear on what it can be used for and what it can't be used for. So this analysis was very much how 30 specific items have changed in the average price. So with web scrape data, obviously difficult to identify location information and things like that. So yeah, very important for us to not claim too much on what people can do with the indicators. So I would only infer how those specific 30 items changed in price, and anything more we will look to put on our backlog.
No, that's very politically sensitive answer, thank you. Okay, well, there is one more really quickly. We've got a minute. Are there any research capabilities at the university that you are particularly interested in, which could act as a focus for future collaborations? I guess that's to anyone.
I mean, I would say I've recently done a visit or two to some universities. I think we are really keen to try and collaborate more with universities. So I think there's two strands. I think there is really interesting research and project work that is coming out of universities that I think we would really love to engage with. we just need to do better at working together, I think, especially now these number of data science functions and teams across government and the public sector and academia are growing. We really need to think about how can we work together on projects of mutual interest and benefit. So I'm all ears for suggestions, but it's something that we really want to think about in the coming months. I think how we can work better with academia, and then obviously the second strand, which is more established, is partnerships on courses and on programs, academic programs for people, so that we are building the next kind of cohort of data scientists and data science leaders through apprenticeships, graduate programs, postgraduate courses, that sort of thing. So the second is more established and we want to do more of, but the first, I think, is something that we really need to try and do better at, identifying those projects for mutual benefit, and learning from each other.
Fantastic. Well, I can see myself popping an invitation into your calendar sometime in the summer for a chat about that. Or we're close, I can just come over. It's only like 40
Absolutely.
minutes. Yeah, so yeah, lovely to speak to you. Thank you so much, Andy, Joran and Elaine, and Penny, thank you. And also thanks to our people in the background, I should say, Elaine, Chiara and James, that helped facilitate the day. And thanks to all of you who've joined us today. So I think there was something like 46 at one point. We lost a few people along the way. Really great. Hope our paths intersect again soon. And for all of you on the call, I hope you continue to enjoy Data Week, and our paths will cross at another event. Thanks everybody. Bye for now.
Thank you.